afternoon, one and all. My name is L.Bhavani. I'm from K.B.N College, Department of Physics and Electronics. Today we are going to discuss about memory devices and logic families. Okay. So these are the different types of memory concepts that are general memory operations, ROM, RAM, PROM, EPROM, EEPROM, EAPROM. These are the different types of memory concepts. So now let's see what is memory. A memory is just like a human brain. It is used to store data and instruction. Computer memory is the storage space in computer where data is to be processed and instructions required for processing are stored. So here two types of memories, that is one is internal memory and second one is external memory. Internal memory means permanent memory, we can't erase it. External memory means temporary memory. Okay, now let's see what is RAM. A RAM constitutes the internal memory of the CPU for storing data, program and program result. It is read or write memory. It is called random access memory. RAM are two types, that is static RAM, that means SRAM, and second one is dynamic RAM, it means DRAM. So now let's see ROM. ROM is temporary, not temporary, it's a permanent memory. So ROM stands for read only memory, the memory from which we can only read but can't write on it. This type of memory is non-volatile. The information is stored permanently. So RAM means it's a temporary. So here we can erase the data. So ROM is permanent memory. So types of ROMs: PROM, EPROM, EEPROM and EAROM. So now let's see in detail about types of ROM. So first of all, PROM. PROM means programmable read-only memory, refers to a type of non-volatile memory that can be programmed by the user or manufacturer to store data or instructions permanently. PROM retains its stored information even when power is turned off. The term read-only memory implies that the data stored in it cannot be modified or erased once programmed. So example of PROM is real-time clock. So real-time clock also we used when power is turned off. Next, PROMs are commonly used in situations where the data or instructions need to be stored permanently. Some applications include firmware storage, microcontroller programming, system booting and calibration data storage. Firmware means it's combination of hardware and software. So microcontroller means inbuilt it have output and input devices also. Compared to microprocessor, so microcontroller is the best example. Next, booting means uploading, system booting. It means day by day it's uploading and new features can be added. So next one is EEPROM. EEPROM means, which stands for erasable programmable read-only memory, is a type of memory chip that can be programmed with data or instructions and retains its content even when power is turned off. Okay, EEPROM means EEPROM chips are programmed are charging or discharge a floating gate within each memory cell. So and they can be erased by exposing the chip to ultraviolet light. EEPROM were commonly used the female storage and microcontroller programming also. Next, EEPROM. EEPROM, this is also memory device. So EEPROM stands for electrically erasable programmable read-only memory. It is a type of non-volatile memory that allows for electrically erasing and reprogramming data. Here we can reprogram. So EEPROM is commonly used for storing configuration settings And calibration means different types of parameters and small amounts of user data or frequently updated data in electronic devices and ranging from consumer electronics to automotive applications and embedded systems. So even when power is turned off, EEPROM operates at the byte level, so meaning that individual byte of zero data can be read, written or erased independently. So it's very flexible device. Okay, next EEPROM is not much that used when compared to ROM, EEPROM. So it means electrically electable read only memory, refers to a type of, this is also non-volatile memory that combines the characteristics of both ROM and EEPROM. EEPROM allows for electrically alerting or modifying its contents, but unlike EEPROM is typically does not support full azure or reprogramming of individual bytes. EEPROM is commonly used in applications where some data or configuration settings need to be changed or updated occasionally. So compared to ROM, EEPROM, but electrically electable memory not much that used. So next, these are the different types of memory locations. So main point is when we are using memory, it means we can store the data and we can receive the data. It's a storage container for different sectors. So mainly in electronics, in digital electronics, memories are play a most important role. Next, coming to the logic family. IC means integrated circuit logic families. So nowadays world run using these ICs, microprocessor or microcontrollers, laptops, any electronic device, any electronic gadgets made up of using these ICs chips only. So these IC chips including different types of transistors, FETs, resistors, etc. So now see some important concepts in IC logic families. These are the different types of concepts: RTL, DTL, TTL, CMOS, NAND, NOR gates, CMOS inverters. These are the different kinds. So now let's see what is logic family. A logic family is a collection of different integrated circuit chips that have similar input, output and internal circuit characteristics, but they perform different logic gate functions such as AND or NOT, etc. Here we can see the block diagram of logic family. So logic family consists of two types, unipolar and bipolar. And PMOS, NMOS, CMOS comes under unipolar and non-structured structured comes under bipolar. In non-structured we have TTL and emitter coupled logics, and saturated we have RTL, DTL, TTL logics. Now we discuss about saturated logic families. So RTL means RTL was widely used before the development of ICs. RTL circuits are made up of transistors, resistors and are the first logic families to be integrated. Here we can see the block diagram of RTL logic. Here we are using 2 transistors and 3 resistors to make a circuit diagram. Here we are using NPN transistor. NPN transistor means N means negative charge, P means positive charge. Here two emitters are connected to the ground and we are giving the input across the base, and we are taking the output from the collector only. So resistor means it opposes the current flow when circuit flows. So this is the block diagram of RTL logic. Next, see the DTL logic. DTL logic means diode transistor logic. belongs to the logic circuits formed by the diode family. Diode means back-to-back connection of p-n junction. So the logic circuit of the detail has input sides connected to the diodes and the output connected to the transistors. The detail has advantage that it has a high noise margin and the higher values of the fan out. So most of the cases we are using DTL logic also. So next coming to the TTL logic. TTL means transistor logic is a popular digital logic family that was widely used in the design of integrated circuits. So nowadays we are going to use TTL logic only. So because it has number of advantages and very flexible to use the manufacturing purpose. So TTL logic circuits are constructed using bipolar junction transistors and resistors. The basic building block of TTL is the NAND gate. NAND means it is a universal gate. So that's why we are using NAND gate to build the TTL logic, which can be used to implement all other logic gates such as AND, OR and NOT gates. TTL gates are characterized by their high speed and low cost. TTL voltages within specific ranges as logic 0 and logic 1. So logic 0 means it is low voltage and logic 1 means it have high voltage. Voltage in the range of logic 0 means 0 volts to 0.8 volts. When comes under logic 1, it have the range from 2 volts to 5 volts. Next coming to the CMOS, NAND and NOR gates. So CMOS means complementary metal oxide semiconductor. NAND and NOR gates are two fundamental logic gates in the CMOS logic family. CMOS technology is widely used in modern integrated circuits due to its low power consumption, high noise immunity and compatibility with a wide range of supply voltages. So most of the cases we are going to use CMOS, NAND gates and NOR gates to implement integrated circuits. Next, CMOS NAND gate. CMOS NAND gate is the constructed using a combination of both PMOS and NMOS. PMOS means P-channel metal oxide semiconductor and NMOS means N-channel metal oxide semiconductor. P means positive and N means negative. So it has multiple inputs and single output. And coming to the NOR gate, similar to the CMOS NAND gate, CMOS NOR gate is also constructed using both PMOS and NMOS transistors. Has multiple inputs and single output. The working principle of NAND and NOR gates are similar. And coming to the CMOS inverter. CMOS inverter, also known as NOT gate, it means reverse direction, is one of the fundamental logic gates in CMOS technology. It performs the logical operation of inverting the input signal to its complementary output signal. A CMOS inverter consists of PMOS transistor and NMOS transistor connected to the specific configurations. So CMOS inverter works. So here we using the FET. So FET means here we using P channel FET and also N channel. So S means, see the block diagram, S means source and D means drain. So and we are short to the source to input and we are connected to the output signal also. These are the different CMOS inverter workings: PMOS transistors, NMOS, and complementary operation and inversion. So now let's see the difference. So so CMOS inverter works. So here these four principles are working principles for CMOS inverter. So inverter means negative charge. So reverse conduction, reverse direction, it will be works. So we are going to take the output at the source. Next, programmable logic devices. So before that programmable logic devices, we are going to discuss about programmable logic array and programmable array logic. So both are similar, but some few differences are there. So now let's see what are some few differences. So programmable logic devices. Now let's see what is logic devices. Programmable logic devices are integrated circuits that can be configured by the user to implement various digital logic functions. They are widely used in digital circuit designs and prototyping. As they offer flexibility and reconfigurability compared to fixed function logic devices. So now let's see. So what is programmable logic devices? So now we are in embedded systems. Embedded systems means and software plus hardware combination. So now let's see. So we have to write the program for the logic, and that logic will be connected to the hardware components. That means programmable logic devices. So now let's see PLA. PLA means a programmable logic array. Is a type of programmable logic device that is used to implement combinational logic circuits. Logic means either 0 and 1. So these logic circuits are made up of different logic gates. So logic gates are in also ICs, so integrated circuits. So different logic circuits are implemented using programmable logic arrays only. It consists of fixed and end means multiplication and a programmable OR. So here OR means past addition, summation. So which allows for flexible logic function implementation. So in PLA we are using two gates, that is AND gate and other one is OR gate. So next one is PAL. PAL means programmable array logic, is a type of programmable logic device that is used to implement combinational and sequential circuits. It provides flexible and efficient solution for custom logic implementation. So this is little bit difficult when compared to PLA logic circuits. These are the two different programmable logic devices. So these are the different types of memory locations, memory devices and IC devices. So this is about digital logic family. So thank you so much.